Hello bachcho, let's read this question. So the question says, benzoic acid is a common standard used in bomb calorimeters which maintains a constant volume. If 1.22 gram of benzoic acid gives off 31.7 joules of energy when burnt in presence of just sufficient oxygen at an initial temperature of 24.6 degrees Celsius, calculate the molar heat capacity at constant volume of the final product mixture if the heat produced is used for increasing the temperature of that final product mixture and the final temperature is 49.6 degree Celsius. Also calculate W and delta U for the given amount, assuming ideal gas behavior. So now let us solve this question, and here the key concept used is calorimetry. Alright, so यहाँ पर क्या हो रहा है? Benzoic acid is used and benzoic acid is burnt. So this is benzoic acid, C6H5COOH plus oxygen gives CO2 plus H2O liquid. So अगर हम इस reaction को balance करें, then here we'll be having 13/2 O2 and here we'll be having 7 CO2 plus 3 H2O. Alright. Now the initial temperature was T1, let us say this is 24.6 degrees Celsius. 24.6 degree Celsius, or in Kelvin this would be 297.6 Kelvin, and T2 is 49.6 degrees Celsius, which is equal to 322.6 Kelvin. Or given it, the given data is 1.22 gram of benzene, 1.22 gram of benzoic acid. So this is present in 1.22 grams. और अगर हम number of moles determine करें, mass of benzoic acid, molar mass is 122 gram per mole. So number of moles is equal to 1.22, that is the given mass, 1.22 divided by 122, which is equal to 0.01. So we have 0.01 moles of benzoic acid. Now 31.7 joules of energy is being released at constant volume. So delta H at constant volume is equal to minus 31.7 joules. Alright, this is for 0.01 moles of benzoic acid. Now we have to calculate the molar heat capacity at constant volume of the final product mixture. So the heat released is equal to heat absorbed by product mixture. Product mixture. Alright, so heat released is 31.7 joules and the heat absorbed by product mixture would be number of moles of product mixture multiplied by the molar heat capacity of product mixture multiplied by the temperature difference. So number of moles multiplied by molar heat capacity multiplied by the temperature difference delta T. Alright, so number of moles कितना होगा product side में? So we have 7 plus 3, 10 moles of compound are being formed from 1 mole of benzoic acid, but we are having 0.01 moles of benzoic acid initially. So number of moles in the product side कितना होगा? 0.01 multiplied by 10. So this is equal to 0.01 multiplied by 10 number of moles multiplied by molar heat capacity, let it be CV, multiplied by temperature difference. that is 322.6 minus 297.6 minus 297.6. This is equal to 31.7 joules. So this is 0.01 multiplied by 10 is 0.1. So 0.1 अगर हम sides को change कर दें multiplied by CV multiplied by this gap is 25. 25 Kelvin is equal to 31.7 joules. So CV would be 31.7 joules divided by 0.1 moles multiplied by 25 Kelvin. So this value is equal to 12.6 joule Kelvin inverse, mole inverse, because we are dividing number of moles in the we are dividing the number of moles over here. So this is the molar heat capacity of the product mixture that we are getting. So CVM, that is the molar heat capacity of product mixture, is CVM is equal to 12.6 joule Kelvin inverse mole inverse. So we know that the heat released at constant volume is equal to the change in internal energy. So delta H at constant volume is equal to delta U, which is given as minus 31.7 joules. So minus 31.7 joules. All right. And it is also given that W is equal to minus P dV, but volume constant है इधर. So dV is equal to 0. So we will get W is equal to 0 and delta U is equal to minus 31.7 joules. This is the required answer, and I hope you understood the concept well. Best of luck.